So this is like type 2 question. I was saying that here we need to find out the intervals also. Here we need to find out the intervals also. And in that case, how do we do? And that interval, we need to say that in that interval, it is strictly increasing and strictly decreasing. These two types of like intervals we are going to find out. For one, it will be strictly increasing, and for the one, it will be strictly decreasing. So let us do that same method we are doing. Same method we are doing. We are having fx. First of all, whatever the function is given, let us write fx is equal to 2x square minus 3x. And f dash x matlab differentiating both the sides with respect to x, which is 2 into 2x. You should remember how to do the differentiation. 2 as it is, but x square differentiation of x square is 2x minus 3, and differentiation of x is 1. So that means it is 2 to the 4x minus 3. So f dash x is 4x minus 3. And that is the first step towards this, that we are going to find out the interval strictly increasing. Let us get one thing. I would like to explain you this in a little bit different way. Okay. And in this, we are going to find out strictly increasing. First thing is strictly increasing. As we have to find out strictly increasing, there are two methods. Okay. I'll show you the easiest. I'll show you the easiest method. Here you can see, if you have side, if you have space at side, please go for side. Okay, whenever we have this one, and we need to find out the interval. We need to find out the interval. Then your f dash x, you're considering that it is 0. And for this f dash x is equal to 0, you're going to find out your value of x. Value of x will be 3 by 4. X, 4x is equal to 3 and x is equal to 3 by 4. So that is the way we are going to find out x is equal to 3. Now just check. If you have 3 by 4, that means we are going to draw like this always in this find out interval. This is the proper method we are going to find out the intervals. So here you have plus minus infinity. This side you have plus infinity. I have drawn x-axis. I have drawn x-axis in which left side we have a minus infinity, right side plus infinity. Somewhere we have origin also, but I don't want to show my origin. I want to show x is equal to 3 by 4. This is our 3 by 4 by 4. So how to find out the intervals? So first of all, fx we have written, then we will find out f dash x, then we'll find out f dash x is equal to 0, considering f dash x is equal to 0. And for that consideration, we are finding out the value of x. We are finding out the value of x. And my value of x is 3 by 4. That means I have, you can see that you can go left side of the 3 by 4 and you can go to right side of the 3. For which the function will be strictly increasing and strictly decreasing. Now for this purpose, you can see that if you go left hand side, it will be like strictly, you can see that if you substitute this value, now we will substitute, suppose in this region, what happens to this my function? Actually, what we need to find out, I need no need to find out f dash x. I need to find out for fx. So my function is increasing or decreasing. So what do? I'll substitute the value of minus infinity to 3 by 4. Now, suppose minus infinity to 3 by 4, what value will be over here? So I know that some minus 1 value will be there. Suppose I'll substitute minus 1 value in fx. So fx will become, it is like 2 into minus 1 square minus 3 into minus 1. So it is like 2 minus minus plus 3. And you can see that 2 plus 3 is 5. So you can see here it is increasing, right? Here it is increasing because you're getting fx is equal to greater than 0. When you have fx is equal to greater than 0, that means it is increasing, right? So that way we can find out. Even we can check with the f dash x. No need to write as of now. Just wait. You're going to draw this. Just wait. I'm going to show you two methods. First one, I'm showing easy one this time. And second one, little difficult one I can show you. So here, if you substitute, suppose you are substituting in f dash x. Okay, suppose you are substituting in f dash x. Then f dash x, if you substitute 4x minus 3. But you can see that for this interval, you can see your x is equal to 3 by 4 is like chopping of this x-axis into two parts, into two intervals. You can see left hand side interval is known as like minus infinity to 3 by 4. And right hand side is 3 by 4 to infinity. That means in one region, it is the function is increasing and the other region, it is decreasing. We don't know in which region what happens. So we are looking forward to find this. Okay, by suppose I have to find out that my function is increasing. My function is increasing and the second is, anyway, let us find out for any reason. Like suppose in this region, you can see, see, in this region, there is one number minus 1. So in this kind of method, we are just going to take any number. Any number. You can take minus 2 also. It's just that we are checking that our f dash x is greater than 0 or less than 0. Okay? You can substitute any value. In this interval, you can substitute any value. It's just we are checking that whether f dash x is greater than 0 or less than 0. So suppose I will put this minus 1. So it is 4x minus 3. So it is minus 4 minus 3. So I'm getting, okay, this time I'm getting minus 7. That means the function actually is less than 0, no? F dash x is less than 0. Less than 0, that means the function is decreasing. I can say that the function is decreasing in minus infinity to 3. And you can see now if I'm talking about the right hand side region, now you can check that right hand side region is this region. Right hand side region is this region. Now in this region, if I will check, now in this region, I'm checking, I need for the checking part, I need to assume some x. What x I can assume? Easy number with it. 3 by 2, 3 by 4 to infinity. 3 by 4, it's like 0.75. So easy number is like 1. 3 by 4 is greater than 1, right? Even the left side part, we would have substituted x is equal to 0. That would be also easy. So let me substitute for this region. If I'll substitute in f dash x, it is like 4 into 1 minus 3, which is 4 minus 3, which is greater than 0. So you can see that this region, this green color part, the function increasing, and in the yellow color part, the function is decreasing. So that is how we are going to check. This is very first question. You might be little like confusing stuff in confusion, but with practice, the confusion will be. And even I can show you one more method, which is even you will connect it very easily for this particular question, but later on you cannot use that method. So that is why I said this method only at the first. So what that method says that if your function is increasing, if your function is increasing, that f dash x should be greater than 0. F dash x is greater than 0. That what is your f dash x? X minus 3. 4x minus 3. So that means it is 4x, both the sides we are adding 3. So 4x greater than 3. Then both the sides we are dividing by 4. So x is greater than 4. That means here x is greater than 3 by 4. Sorry, x is greater, both the sides we are dividing by 4. So is greater than 3 by 4. And that is how in increasing x greater than 3 by 4, greater than 3 by 4. Matlab, if you go right hand side of the x-axis, obviously greater than, meaning we go right hand side. Matlab, which region, you can say greater than, it is not equal to sign so that I can put that box, close bracket. Here I have to put open bracket, okay? Open bracket, and that is why 3 by 4 to infinity. Any value you can take, strictly increasing. I know that you will connect to this kind of second method easily for this question. For this question, mind well, later on, you will be comfortable with write whatever I have shown you this before part. Okay, these two are different methods, and strictly decreasing, you should write both methods for this, but later on we are going to use only one method. F dash x again, I should choose that strictly decreasing. We are finding strictly decreasing when the function strictly decreasing, so f dash x is less than 0. Now what is f dash x? It is 4x minus 3 is less than 0. Let me add 4x, let me add 3 on both sides, and let me divide by 4 on both sides. So I got that x is less than 3 by 4, less than 3 by 4. Meaning you can take any value from minus infinity up to 3 by 4. It's not less than or equal to. You remember we used to write like, suppose it is a comma a b. Okay, this is like close bracket. So in that case, suppose x belongs to a. So in that case, we used to write that a is less than or equal to x less than or equal to because of this bracket. Okay, because of this. But suppose your bracket is open bracket. So in that case, we put a less than x less than b. So that is how it is difference between that two brackets. So here we can write that in this region, so in this region, it increasing, and in this region, it. So ultimately, the answers for both is how we started. We started with the fx. Fx made differentiation on both sides. F dash x we found from f dash x. If you want to find out with the easy method for this question, f dash x is greater than 0. If it is greater than 0, your function will be increasing. Let me put this, whatever f dash x is. Let me find out with this method. I got this easily. And if it is decreasing, that again, it does not. Next question. Fifth one. Find the intervals. Here again, we have to find out the intervals, whether the function is increasing in this region and decreasing in this region. So I don't know whether your book is saying strictly increasing or strictly decreasing. If it is so, let me know.
I didn't complete the previous one.
Oh, did not complete?
No.
Okay, fine. Let's see. These two are different methods. You can write any one of them. For this, you can write left part, right side. You don't need to. Done?
Yes, sir.
Done? Yes. So next question is like when I copied, from the PDF, online PDF NCRT, from there I took only increasing and decreasing, but I guess this is strictly increase and it's strictly decreasing function. You just check in your.
Yeah, ma'am, it's strictly increasing and strictly decreasing.
Yes. So that's what we are going to find out two intervals, one for strictly increasing and one for strictly decreasing. Let us start our basic thing. We start with fx. Fx is 2x cube minus 3x square minus 36x plus 7. We'll find out differentiation, which is f dash x. X is like 2 as it is, x cube 3x square minus 3 as it is, then x square ka differentiation 2x, then minus 36, differentiation of x is 1, plus differentiation of constant 7, 0, plus x is equal to 6x square minus 6x minus 36. I know that we can take common, 6 can be taken common. We always get the f dash x in the smallest form. we always try to get our this thing f dash x in smaller and smaller. If I would able to get in the different brackets, it will be great. We don't want in expansion form, we want in that fraction part. Okay, so we want in different brackets. So I can see that we can like inside I'll do that. I can split the middle term. It is like 6, that means, and I want to 1 here. 3 2s are 6, and I showed you we can do it directly actually, x and x, right? And 3 2s are 3 2s are, so 2 and 3, fine. As you can see that both multiplication gives us -6. That means one is negative and one is positive, obviously. But which one is negative, which one is positive? So this middle term sign is -1. That means greater number is minus and smaller number is, both will have different signs. So that 6 is negative. So that is the logic we used to have to find out this splitting the middle term. Now, as I told you, whenever I need to find out the intervals, I just assume that whether this f dash x is 0. Is 0. So with that method also we can find out. With that method also we can find out, or we can use that this method also, which just now we did. But this will be a little tricky because you can see 2 brackets are there. But I can see one thing easily. If I'll do this one 0, no, this method I can show easily, because you know what is f dash x? 6 into x plus 2 into x minus 3. That means I can have 2 values of x. You can see when multiplication of these 2 bracket is 0, that means whether x plus 2 is 0 or x minus 3 is 0. If I would take x plus 2 is equal to 0, that means x is equal to -2 or x is equal to, I would have 2 values of x. Again, we'll go to our funda. What we have to do, we want to find out where this function is strictly increasing. Very first thing we want, that is find the interval where the function is strictly increasing. Now I got 2 values. Remember the previous one? We drew after getting value of x, we put that value of x on number line. You remember 3 by 4? We put on the number line extend to minus infinity to plus infinity. Just like 11th also we had one this kind of linear equality and all. We did used something like that. Okay. So here I can say that x is equal to -2 and x is equal to 3. These two are going to divide the number line. Divide the real line, number line, the real number line, into how many parts it will make. We have 2 numbers. If I would have a 1 number, it will make 2 different intervals. But if I have 2 numbers, it will make 3 intervals. So real line into 3 distinct intervals. How? Because see, I'll show you. Okay, here I'm not next slide. I'll show you again. We'll go back to that. I have 2 numbers as you already found. Okay, x key, like this side it is minus infinity, this side it is plus infinity. Here it is -2 and here it is 3. Obviously, left side minus sign. It is like 0, okay, left hand side negative thing, 0, okay, right hand side positive thing. We don't want 0 and all, so we didn't show that. It's just -2 and 3, right? That means here you can see that we are having 3 different disjoint. They are not connected. We have open brackets, right? So it is like disjoint intervals. T2. So that is how you can see. You can see that. Sorry, I took back side. I went back and look. Three distinct intervals. Which three intervals are there? So you can see minus infinity to minus 2, then minus 2 to 3, and then 3 to infinity. We made three intervals like this. Again, we started with fx, we found f dash x. We consider that where this f dash x is 0 and f dash x is 0, that means we got two values of x, and which we put on the number line. These two values we put number line, and these two values are going to divide the real number line into three disjoint intervals. Three disjoint intervals are given on the screen, and on these from these three intervals, we are going to find out by which interval it is the function fx is strictly increasing. Matlab your f dash x is greater than 0. We are going to find out your f dash x is greater than 0. So when I'll take three different part. Matlab, suppose in this region I'll discuss. Okay, suppose in this region we are talking this region. Talking about this region. So that means what is your f dash x? Which value should I take? So x is equal to between minus 2 and infinity. Which value is easy to substitute in f dash x? Obviously minus 3. Minus 2 I cannot take. Minus 3. Minus 3 is easy, right? So here, what is there? Our function was x minus 6. 6 to positive only, by the way. 6 is positive. And then x minus 3. X minus 3. That is minus 3 into minus 3. That is like 0 only. Minus 3 into, sorry, minus 3 into minus 3 matlab is negative only. Minus 6 matlab negative. And you can see that it's minus 3 into plus 2. Minus 3 into plus 2, it's minus. You're getting what did I do? Okay, I'll show you one other. I'll write everything now. You can wait for these 3 questions, and later on we can write. Okay. Here what I'm doing, I have assumed for this interval, I have assumed that suppose I am putting x is equal to minus 3, then what happens? 6 remains 6 as it is, then minus 3, then minus 3 plus 2. So that is how you can see that this is the positive only. This one became minus 6. So it's like minus 6. And this one is minus 1. So you can see that the first one is positive. So suppose if I need to make a table. If I'm in need of making a table. This is intervals. How many intervals do we have? We have 3 intervals. And then the function, sign of the function, because sign of function only will decide by how the function behaving, whether it is increasing or decreasing. That is called nature of function. Nature of. So here in the first interval, when I put x is equal to minus 3, later on you will put directly. Here for practice purpose, we are writing everything. Later on, you will put directly. So here you can see that this is positive only, plus 6 is positive, then minus 6 is negative, then minus 1 is negative, and minus plus. So you are getting greater than 0. Getting greater than 0, your f dash x is greater than 0. Here also you can check 6 are minus 12, and 1 is like minus 1, and that is how it is plus 12. So when you substitute x is equal to minus 3 from that interval, your f dash x is positive. Positive matlab your function is strictly, nature of the function is strictly increasing. Second part, which is minus 2 to plus 3. Oh, minus 3, plus 3. Now in this region, what do? I'll take value minus 2 to plus 3. Easiest value we can take, which is 0. Any value you can consider. It's like We choose the easy one. 6 as it is. Then it is 0 minus 3. Then it is 0 plus 2. So you can see that this one is positive, 6 is positive, minus 3 is negative, and 2 is positive. So you can see it's like this is positive. Later on, you will be able to write direct table. Here we are checking with this method. Later on, you are going to make a table and directly you will put and check with practice. Yes, it's positive. And second one, you got negative as you put x is equal to 0. So you are putting, where are you putting? So you are putting in f dash x, right? Okay, you're putting in f. What is your f dash x? If you remember, it is 6 x minus 3 into x plus 2. Here, if you put x is equal to 0, this is like chalo 6 only. Then 0 minus 3 is minus, and 0 plus 2 is plus. So plus minus 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 same like it's odd time negative, that means less than 0. Less than 0 matlab your function is strictly decreasing. Ultimately, we are trying to find out the sign of f dash x in different intervals. That's it. We are just taking a random value from that interval and we are substituting for the check. From minus 3 to, sorry, minus, right? Plus 3 to infinity, easiest value will take x is equal to 4. And your f dash x is 6 as it is, then 4 minus 3, then it is 4 plus 2. That means it is like plus, then plus, then plus, all plus. Because 6 is also positive. 4 minus 3 is 1 and 4 plus 2 is 6. All are positive, greater than 0. Strictly easy. Strictly. That means the question was in A part, it was we have to find out the function in which the function is increasing, and the second part it was strictly decreasing. So we found it is strictly increasing in this region, strictly increasing these two part, and strictly decreasing in the minus 2, 3. At 2 different intervals. 3 different intervals, but from which 2 are giving strictly increasing and 1 is having. Still, one more will be required for practice purpose and you will be champion. Let me explain one more time. So, see, what do we have to find? Here I needed to find out in what that particular function is somewhere it is increasing and somewhere it is decreasing. So that intervals we have to find out. So, okay, from this to this part, it is increasing because see, it is a polynomial function. It is a polynomial function, meaning if I want to draw a graph, it might be somewhat like that or whatever it is, whatever the graph is. I don't know in which part it is increasing, in which part it is decreasing. Okay, so in somewhere it is like somewhat different. Here we can check that in this interval it is increasing, then we can check in this region it is decreasing. So we want to find out that interval for which it is increasing, but some it is decreasing, right? It is not the correct curve I have drawn. I have just randomly I just moved my pen. So here, first of all, we took fx, then we did differentiation, simplification we should do in such a way so that we will have different brackets. Why so? Because we are considering that suppose at some point f dash x is 0. If my f dash x is 0, what does it actually mean by, f dash x is 0? Just try to understand the analogy of it. When you have a curve, f dash x is 0, that means at that point your slope is 0. Slope matlab dy by dx or slope matlab f dash. Try to understand this correctly. You are finding some point Okay, you are finding that particular point for which your slope is 0. That means your f dash x is 0. That means maybe left hand side it is decreasing or increasing, and right hand side maybe increasing or decreasing. Because at this point it is 0, slope is 0. So now maybe it will go up, increasing, or maybe it will go down. This is how we check for f dash x. F dash x is 0. Okay, and that means we will get two values of x, and these two values are making dividing the real line into three intervals. We made three intervals, and from these three intervals we are just taking any random value. Any value you take, substitute f dash x. If your f dash x is positive, your function is increasing. If your f dash x is negative, your function is strictly decreasing. But if it is greater than or equal to 0, then less than or equal to 0, we need to have that it is only increasing, only decreasing. Okay? Strictly matlab only greater than or equal to sign would not come. So that's it for this fifth question. Let's go to sixth. Same manner, you will be champion with this one. It will make you confident for after this. That here we have some function. Okay, suppose we have this function and we need to find out the intervals for which these functions are. Here we have in A, B, C, D. We are going to do some questions. This is strictly increasing and decreasing function. Let us assume that it is fx. Was not given naming. We did naming also. We'll do f dash x. F dash matlab ye x square ka 2x and 2x ka 2 minus 5 matlab ye 0. So f dash x is by the way 2x plus 2. F dash x is 2x plus 2. That means suppose if I'll find out okay, by if it is 0, this x is 0, that means 2x plus 2 is equal to 0. That means x is equal to minus 1. Is equal to minus x is 2x is equal to minus 2, and x is equal to minus 2 by 2. X is equal to minus 1. That's how we get. That means this x is equal to minus 1 divides real line into two intervals. Minus infinity to minus 1 and minus 1 to positive. How? Because I know that this is a real line, minus infinity plus infinity, but this somewhere the function becomes, slope becomes 0, minus 1. At minus 1, the slope becomes 0. That means it is giving two intervals, minus infinity to minus 1 and minus 1 to infinity. So it is, so we have only only one number. That means real number line is divided into two intervals. If we have two values of x, that means real number line is divided into three. Three, then 4 parts. So you understand that the one will be extra. One will be more. Yes. So here we are going to do the direct one, that suppose you have intervals, because since we have only two intervals, okay, then the sign of f dash x and nature of fx, nature of function, it matlab fx, right? So what do we have to do? The intervals may, we will write two intervals, minus 1 to minus infinity and minus 1 to positive. Now let us work on sign. This is the main thing. This is the most important thing, is to find the sign. From minus infinity to minus 1, if you see which number will be like very easy, if I would take, I can solve easily. So if you just take minus 2, Obviously, minus I would not take like a, suppose 10,400 minus 10,000, because minus side minus 10,845. I will not take such number. Obviously, if it is starting with -1, I'll take some simple number -2, and let me check the sign. Okay, if I'll check the sign of fx, that means I need to substitute in this top effect f dash x. So 2 into -2, that means -4, -4 plus 2, -2, which is giving me 0, which is giving me less than 0. Yeah, less than 0. Check, check, you can check it side. F dash, if you are finding x, if you're putting -2, then it is 2 into -2 plus 2, -4 plus 2, it is -2, less than 0, obviously. That means your function is strictly decreasing. Let us find out for greater than 0, which value would I take in this region? Very simple. -1 to infinity, 0. I'll take 0. Suppose I'll put in f dash x, if I'll put, here I will put 0. 2 into 0, 0 plus 2. That means the function is strictly decreasing. Now, if you have doubts at this point, you can ask me in any of the question, or even in like past, in any question or any condition you are not understanding, you can ask. I had to teach at least 3 questions so that you will have some doubt, and now this is the time to clear the doubts. Now we have the question B. Now we will go a little faster. Fx is naming ceremony, 10 minus 6x minus 2x square. I know that in each and every question, if I'm finding increasing, strictly increasing, if this x is necessary. Second step, so 10 is like 0 only, minus 6x minus 6, and minus 2 into 2x, minus 2 into 2x, that means minus 6 minus, that is the differentiation part. Now if my differentiation is 0, okay, f dash x is 0, that means minus 6 minus 4x is equal to 0. In that case, 4x is equal to minus 6, and x is equal to minus 3 by 2 once you find out this one. 3 to 6. That is how we can cut values and we get x, only single value of x. Single value of x, that means this x is equal to minus 3 by 2 divides real line into 2 intervals, 2 disjoint. Disjoint word was missing, I guess, in the previous one. This 2 disjoint intervals. Disjoint matlab they are not in overlapping intervals. How it is dividing, so let's draw and understand. If it is minus infinity plus infinity, and somewhere it is minus 3 by 2, anywhere you can put minus 3 by 2. So you have 2 intervals, minus infinity to minus 3 by 2, and here minus 3 by 2 to infinity. So intervals minus infinity to minus 3 by 2 and minus 3 by 2 to. Let us find out with the intervals and all. Intervals, and then sign of f dash x, and then nature of function, nature of function, nature of f dash x. Let us write down intervals, 2 intervals only, minus infinity, 3 by 2, 3 by 2 to infinity. Here you can see that from the left interval, which value will be easy value, so that I will get the minus 3 by 2 is nothing but minus 1.5. The easy value is like which value then? It is like minus infinity to 1 minus 1.2 will be very simple, minus 2. So suppose I am taking minus 2. So I will take minus 2 because from minus infinity to minus 3/2 there will be some value which will be easy. If you are getting confused, you can take minus 4, minus 6, minus 10. Fine. Just try to put in f dash x. If you try to put in f dash x, you will get minus 6 minus 4 into minus 2 f dash x. When you put in f dash x, you should not see f dash x is 0. Okay, you have to put in pure f dash x, not this we made 0 and after that. Why we made 0? We just wanted a point where the slope is 0, because before that it will be decreasing or increasing. So we just wanted the interval part x for which it is decreasing. That is why it is minus 6 plus 8. It is greater than 0. 2. That is greater than 0. That means it is greater than 0. Nature function is strictly infinite. In this region, if you, which value is simple, so it is 0, minus 2 to infinity, we'll take 0, minus 6 and minus 4 into 0, minus 4 into 0 is 0, so answer is minus 6, which is less than 0. That means it is strictly decreasing. Start with the C1 equation. Number 6, C. It is again fx is equal to minus 2x cubed minus 9x squared minus 12x plus 1 plus x is minus 2 3x squared. And just we are differentiating both sides. Minus 6x squared minus 18x minus 12. You can see that here I have to take a minus 6 common up. Minus 6 common. Inside it is minus x squared plus 3x plus 2. You can see we can split the middle term. 2 ones are 2 and 2 and 1 is 3. Minus 6 will we are, what are we doing? 2 ones are 2 and 2 plus 1 is 3. 2 plus 1 is 3 and both signs are should be positive only. Minus minus plus or plus 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 multiplication. But here the sign of 3 is positive. That means both are plus only. 2 ones are x plus 1 and x plus 1. Next step is simple. F dash x we make 0. That means this full whatever we found on top is 0. And that means it will give us two values of x. If I'm getting two values of x, that means these two values of x divide a real line into 3 disjoint intervals. Then we'll write down the intervals. X is equal to minus 1 and x is equal to minus 2. Divide real line into 3 disjoint intervals. One will be minus infinity to minus 2, then minus 2 to minus 1, and minus 1 to. Check this, you can draw the line. Better to do by yourself. Once you will start doing by yourself, you will make some, you can easily find out some tricks also. There is some trick, I can use this trick to find. There is no space. So we have to draw a line. Minus infinity plus infinity 2 points, and it is -2 and minus. As we put on number line, we have to take minus and plus sign accordingly only, but no need to see the gap between them. It's completely fine. We just try to understand the intervals. So these intervals are like -infinity to -2, -2 to -1, and -1 to infinity. So here I'll take some value like -3. Here I'll take value which is like -1.5, and in this interval I'll take 0. 0. So that way we are going to, these three are our understanding. Teacher don't want this. This is our trick. Huh? Okay, this trick we will not share. Okay. So like intervals, sign of f dash x, and nature of function. Intervals are -infinity -2, -2 to -1, and -1 to. What is the sign? Sign of f dash x. Once you try to put in first interval -infinity to -2, we are putting -3. Where we are putting, that is more important. We are not going to put an fx. We are going to put in f dash x only. F dash x. If you put in f dash x, which is, you can see this one. Oh, sorry, this is like equal to 0 wala part. Sorry. I'm going to highlight that part in which we are going to put actually all the values. Okay, there is -6, but here if you put value, but before that one already negative thing is there, -6 matlab negative. Then once I'm putting -3, okay, I'm using -3. So -3 plus 1, in -2 negative, and -3 plus 2 again negative. So that means all the values are negative, minus, plus, minus, negative, and will give you decreasing. It's like strictly less than 0. Less than 0 meaning f is strictly decreasing. Strictly decreasing. Let us take some value 1.5 minus 1.5. So -6 matlab it is negative only. Then -1.5 plus 1 matlab again minus sign. And -1.5 plus 2, which is plus sign, greater than 0. So strictly increasing. Strictly increasing. Then -1 to 0, we are putting x is equal to 0. -6 matlab minus only. 0 plus 1 positive, 0 plus 2 positive, less than 0, strictly decreasing. Yes. Strictly. How we get that? We wanted intervals, then you need to find out okay, by in which interval is it given. MCQ question. MCQ you need to find. After doing this exercise is important for a competitive aspect. This D1, D is right away. I'll show you E1. You can see x square. X की value 1 you will get. Okay, 1 you will get, one value of x you will get. So 2 intervals you will get. One will be increasing, other will be decreasing. Let's do E part. I have to show you E part. You can see the power of cube and all. We are not going to open the brackets now. We might solve x plus 1 whole cube, x minus 3 whole cube. F dash x meaning these two are in product, they are in multiplication. Product rule will apply. First quantity as it is. Differentiation of minus 3 cube plus x minus 3 the whole cube as it is. Differentiation of x plus 1. X plus 1 cube as it is. Then if you remember, what is the x cube, like differentiation of x cube? It is 3x squared. So let first of all we'll have to apply the power rule. Okay. Once we had to apply the power. After we solve the power thing, we have to differentiate. It was not x because the formula says that if it is x, then only the answer is n into x into to the power n minus 1, right? Where n is equal to 3. Here it was 3, but x was not x, it was x minus 3. When x is not x, something else, that means chain rule should be applied for that thing. It was not x required. Again, the same rule, power rule, and then chain rule. X plus 1 cube into 3 into x minus 3 whole cube. It is x minus 3. Okay, x minus 3. X differentiation is 1 and minus 3 is 0. So it's like 1 only. No need to write. So let's leave like this. Minus plus x minus 3 whole cube. 3 x plus 1 square. Let's take 3 common, x plus 1 square common, x minus 3 square common. Here it is 2 by the way. Let's take some common from these two terms. 3 is common. X plus 1 square is also common. And x minus 3 square is also common. What left in the first term? You can see x plus 1, the whole cube message. Square is gone. That means only x plus 1 remained. Plus, in the second term, we have x minus 3, the whole cube. Square is removed. X minus 3 remained. Which only remained. Let's add them. So I'll get 3x plus 1 square, x minus 3 square, x and x is 2x. It is like 2x minus 2. Again, we can take 2 common to make simple. 3 to the 6. Because ultimately we are going to check its substitution. It is very simple actually, but I'll explain you why. Okay, this is your f dash x, which is very important to check whether f dash x is greater than 0 or less than. Actually, we substitute in this only. But you can see that this we have to make 0. If we consider this 0, that means all 3 multiplication product is 0. That means it might be minus 1. X plus 1 square is equal to 0, matlab x minus 2. Or x is equal to 3. From this bracket, I can get it is 3. And from this bracket, I can get that it is 1. So it may be minus, it may be 1 and 3. That means these 3 points, these 3 values of x is what it is doing, dividing real line into 4 intervals. Here we are having 4 intervals. Right? Now, x is equal to minus 1. Order may I'll write in order. X is equal to 1 and x is equal to 3. Divide real line into 4 disjoint intervals. Which one? Minus infinity to minus 1, minus 1 to 1, 1 to 3, and 3 to infinity. If you don't understand these, no, so that is why we have this line. It's minus infinity minus 1, 1, and now you can see that this interval is minus infinity minus 1, minus 1, 1, 1, 3, and 3. Only one thing remains. Sign of f dash x. Nature of function. Intervals minus infinity minus 1, minus 1, 1, 1, 3, 3. Sign of f dash x. Put this in f dash x. We have to have that highlighted one yellow color line because we are going to put values here only. Okay. But you know what? One thing you just understand. If I'll have minus 1 square, minus 5 to the power 4, it will be like very big number but positive only. Okay? It is like 625, but it is positive, right? That means even power of the bracket, even the negative number, even power of negative number is also positive. So that means these two brackets, anyway, if you take infinity also, negative side, infinity side, minus infinity, you consider and put as x. But ultimately, you are making square of it. We'll make it easy, is one, it will make positive only. So you know that three things are positive over here all the time. First of all, 6, which is always positive, which is always positive for all the intervals. Then the next thing you can see, x plus 1 square, positive all the time. Then x minus 3, same thing, square, positive. No matter what value you are substituting, you'll get positive. That means everything depends on whether the function is increasing or decreasing. That thing depends on x minus 1 only. So the matter is of x minus 1. Let us put one by one from each interval. If we are talking about this first interval, minus infinity to infinity, I'll take minus infinity to 1, I'll take minus 2. Suppose I'm putting minus 2 over here in as a x value, then minus 2 minus 1, it is minus 3. This negative number, less than 0. Negative. Oh, where? If you multiply plus, but last one is negative, less than 0. That means the function is strictly next is minus 1 to 1. X is equal to 0. Will take. You can see that it depends only on x minus 1. 0 minus 1 is again minus, less than 0. Minus 1 is minus 1, less than 0. Strictly decrease. Then 1, 2, 3, I'll take x is equal to 2. Very simple. X is equal to just directly 2 you take. And you can see 2 minus 1. 2 minus 1 is 1, which is positive. Is greater. Strictly increasing. And then 3 to infinity, take x is equal to 4. X is equal to 4. This 4 minus 1, 3, positive. Strictly. That means 2 are giving is strictly decreasing, 2 are giving strictly. So that is how we can make, that is revise again. What we needed to find? We needed to find in which interval the function is strictly increasing and strictly. We had function, we gave the naming also, fx is our function, f dash x is what's needed to find. We applied the product law. How you applied the product law? Yeah, that concept should be clear from 5th chapter. Otherwise, this chapter is impossible without 5th chapter. Then f dash x, once you have expressed this, you have to minimize it into different brackets. And as you have done that part, we need to identify whether at what point it is 0. So we are getting 3 points. X is equal to minus 1, 5 plus 1 and 3. How we got? We had 3 brackets equal to 0. number goes. That is how we get. That means I can find out if I have value 3 possibilities of x is equal x value. That means I have 4 intervals, 4 disjoint intervals. It's dividing the this function into 4 intervals. Dividing in 4 intervals, and that is how you can make out the intervals. Take one value, put in f dash x. This here we understood. Okay, how do we put for all? We can actually put for all values of x and all, but I took a little fun. 6 is always positive. I wrote positive. X plus 1 is square. That square always positive. Again, one more bracket with a square. It's positive. That means I needed to identify where this x minus 1 is negative. And how we take this. That was actually not so difficult. Let's go further. So I have y log 1 plus x minus 2x. 2 plus x. 1 2 plus x. Here it is given x is greater than minus. Show that this is increasing function of x. We have to show that it is increasing function of x throughout its domain. Domain matlab here it is given x is greater than minus 1. Matlab minus 1 to plus infinity. Greater than 0, greater than this, minus infinity. Minus 1 to infinity. X belongs to minus 1 to infinity. Greater than anywhere. First thing we should do, that is differentiation. dy by dx, both the side, if I would, the log of differentiation of log is 1 by x. But it's not x, it is 1 plus x. That means again the differentiation of 1 plus x is required, but differentiation of 1 is 0. Differentiation of 1 is 0 plus differentiation of x is 1. 0 plus 1. So 0 plus 1 is 1 only ultimately. So that is why it is 1. It was not required to put, it's just noted. So that we have used. Okay. So nahi kisi ko dikhana nahi hai, but to remember that if in place of x 1 plus x, if you have x square, then the scenario would have been different. Here the quotient rule, denominator as it is, differentiation of numerator minus numerator as it is, differentiation of denominator square. Dy by dx is equal to 1 by 1 plus x minus 2 plus x, 2x ka only 2, minus 2x, and then no, 2 ka 0 and plus x ka 1, that is 1 only, 2 plus x. Dy by dx is equal to 1 by 1 plus x minus, if I open the bracket, let me open the bracket, 2 to the 4 plus 2x minus 2x upon 2 plus x whole square minus 2x plus 2x got cancelled. So dy by dx is 1 by 1 plus x minus 4 upon plus x. This is not enough actually. You know this. What do we have to do? We have to get in the smaller bracket. Let us take LCM. That means this denominator will multiply here, this denominator multiplies over here. 2 plus x whole square minus 4 into 1 plus x upon both the denominators are going to multiply here. Dy by dx is equal to, we have to open the bracket, a plus b the whole square, 2 to the 4 plus 2 to the 4x plus x square minus, open the bracket and negative sign. Be careful when you have negative sign outside. Silly mistake. Avoid silly mistakes. Bye bye. X is equal to minus 4 plus 4 got cancelled, minus 4x plus 4x got cancelled. X square upon 1 plus x into plus xt. Now we needed to prove. What do we have to prove? Actually show that this function, so and so function is increasing. Increasing we have to show. Domain, X domain. Domain of X. Where is the domain of X? It's not mentioned. Yes, it is mentioned. X is greater than or equal to -1 is domain. Domain matlab from where you are going to take value of X. So here it is given. X is greater than -1. That means what about x square? X square is always positive. That means we are going to take x belongs to -1 to positive infinity. Now we know that we need to identify. Now we are going to prove that it is increasing function. Increasing matlab your dy by dx is greater than 0. That I have to show. Greater than or equal to. It is not strictly, I guess. It's not NCR default. Now it is only increasing. Only, let us revise, only increasing. It is first time it came only increasing instead of strictly increasing. Strictly increasing matlab f dash x is greater than 0. If f dash x is greater than or